Hey, let's talk about motors. Okay, what do we got? Chances are in your robotics project, you're going to want to use some motors. And here I have a collection. These are brushed DC motors. Now, down here, what I also want to mention is one thing you're going to find in common among all of these motors is if you plan on controlling their speed and direction, you're going to need something like this, one of these guys. Now, these are two fairly inexpensive H-bridge motor controllers. And what they do is allow you to, through PWM or digital control, you can control the polarity of the power that's getting sent to the motor. And by controlling the polarity, you control the direction. And you also control the voltage. And by controlling the voltage, you control the speed. So this is a two-motor controller, this one here, and this is a single-motor controller. One of the things you'll notice, this is a L298 based one, and this is a IBT2 or a 7960 based one. This is a rated for much higher current. This is only a couple of amps, whereas this one I think goes all the way up to something like 43 amps. So this is for your bigger motors, and this is for your smaller motors. And each one of them will have connections. You'll have generally your motor connections and your battery connections are going to be these big ones over here. And they're going to carry, you're going to have the power from the battery come in, and then the connection to the motor go out. And the smaller pins are generally the ones that are from your microcontroller, or if you have something more elaborate than these, like if you have a RoboClaw controller or something like that, you might have it connect directly to your RC controller or something like that. There are ones, even smarter ones. These only cost, these are under 20 bucks a piece, certainly. You can probably get them even much cheaper than that on eBay, for instance, if you get them direct from China or direct from other manufacturers. But something like a RoboClaw is going to cost you more like in excess of $100 or something like that, because that one has actual microcontroller and control built into it, and that'll do things like, take a direct PWM control from your RC receiver and things like that, and also have things like fancy features like regenerative braking that'll send voltage back to your batteries, and cool stuff like this. This one actually has an additional nice feature. You can have current sensing on it, so you can kind of monitor it and see how much current it is supplying, so you can use that for balancing. Anyway, those are our two controllers, and you need those with a DC motor if you want to control the speed and direction. You're going to have to set aside 2 or 3 pins on your Arduino or your microcontroller to deal with those. So we're going to hide those up there for now. Okay, bunch of different motors. Now, chances are, starting out, you're probably going to have dealt with one of these type of motors over here. And these are your typical little gearbox motors, your little Spur gear motors. And these are inexpensive ones. Each of these is probably, under, these two here specifically, I think they're under 10 bucks on Amazon. And if you just look for brushed gear motor, chances are you'll find things like this. Now, a lot of these smaller ones, these little micro motors, and there's some specialized ones like this. This was pulled out of a Canon, I think a Canon scanner or a printer. I forget where that came from, but it's kind of a fun, odd motor. And some other ones that we have kind of grabbed and repurposed from other applications. But this one here is a good one. Actuator is part of Servo City, or they are Servo City. It's hard to say, but if you buy motors from Servo City, you may see the Actuator brand on them. And these are their economy gear motors. Now, to talk about each of these motors, what you'll find all in common, it's a combination of a brushed motor and then some type of gearbox up here. So that's the two parts you're seeing there. And let's see. So here's the motor part, and here's the gearbox part. And that's common across almost all of these. So this is a simple spur gearbox. And what that means, spur gears are like these sort of gears here. You know, kind of what probably comes to mind immediately when you're thinking about gears. So what they do is they reduce the RPMs from the raw RPMs from the motor down by some factor, some gear ratio. So they do that by, say, imagine this little gear is the one that's on the motor itself. You know, maybe these two motors here are just raw motors. They don't have a gearbox on them. They're kind of cool that way. And so they're meant to be used with a gearbox of some kind, because they operate at very high RPMs. Like this one is 18,000 RPMs. So that needs to be geared down significantly if you're going to use it with a robot. So typically, you'll have some type of spur gear on your motor, and then it will engage with another gear, like maybe it'll engage with this larger, so you have a reduction, right? So for every rotation here, you get some proportion of a rotation there, right? So that's going to give you more power. Every time you reduce your speed, you gain some power. And you might have a more complex gear train. Let's see, how can I do this? This one feeding this one, so that's a reduction, and then that one might do that one, so that's another reduction. That sort of thing. So that's a sort of a spur gear train. Now normally they're much smaller and they're kind of layered on top of one another, which is how they get into like these form factors. So this one here is a 56, I think, yeah, it's 56 RPMs, and that's about the speed that I like to use, somewhere around 60 RPMs for a lot of the, like the BB8 functions specifically. So this is a 60 or 56, and these are all generally meant for like 12 volt operations, and you can operate them at higher or lower voltages, but they're, ballpark 12 volts. Now this, being a spur gear motor, the problem, or not problem, but one of the things about a spur gear motor, you'll notice the gears attach and they touch really just in a few teeth, right? So if you stall them, basically if you try to stop and change directions real fast, things like that, there's a point of failure that's a couple of teeth on there. Now, some motors are going to have all metal gears, so that's going to make them stronger, but other ones might have a few plastic gears in there. So what may very well happen is in stressful applications where you've got a lot of torque, you may break a tooth on here. So not that they're bad, but they have that single point of failure. Now they're also very economical. These motors, even the Actuator or the Servo City, these motors are something like less than $20 for a good one. Okay, so those are our general spur gear motors, and they come in all sorts of different RPMs and so on. These are our raw motors. This one is actually from a motorized scooter I took out, and you can see it's been sitting in our shop or shed for a long time, which is why it's nice. And it's a big beefy motor though. It's lots of power in there if you geared it. This was run by a belt. This is actually quite a beefy little motor here, but it's very high RPM. Building a gearbox is not a trivial matter because of those high RPMs. So there's some raw motors. Here are some of my personal favorite motors down here. These are Planetary gear motors, and if you look here carefully, hopefully you can see that, this is an example of what's going on inside a Planetary gear motor. So when you drive the motor, you drive it through a single gear, like this one in the middle, but that gear will engage with 3 other gears, and it could actually engage with any number, but typically in Planetary gear motors you do see this kind of 3-to-1. And as that turns, it turns these 3 gears, and they move as planets. They basically, they orbit around the sun gear, and that causes them to rotate, and then they can rotate yet another gear, and you can kind of make these stages. And they're nice because they do provide that kind of opportunity for reduction in speed and gain in power, but they also have a lot more bearing surface when it comes to the teeth on the gears. You'll see like these are, you know, engaging a lot more teeth, so they're going to be stronger. Now here we have 3 examples, and I'm not going to take these gearboxes apart because these are a step up in terms of the price on here. I have a couple of Actubotics, again the Servo City ones, one of their precision planetaries, these little guys. These are surprisingly powerful for their size. You know, it's a nice little motor there with a 4mm shaft and a nice all-metal gear train here, and that's a Planetary gearbox. And these are about $27, $28. And then the next step up in terms of Servo City are their big HD Planetary gear motors. And they have a much bigger gearbox and a 6mm shaft, and you can get them in all sorts of different gear ratios. And they have a nice beefy motor on here, which is similar. I don't know if it's the exact same motor, but if you see this this other motor right over here, similar in terms of that size. So the power of a motor, you're going to see largely the amp draw and how many amps it will draw when it's stalled and so on. And these are beefier than you're going to want to run with a, you know, like a little driver like this, which is why I like the BT 7960s and Roboclaws and things like that. So the bigger motors, especially the motor part, the bigger the motor, chances are the higher the amps, the higher the power of the motor, if it's a good motor. So think about that in your choices. These are nice. I like these. And this one here is a Lynx Motion, or Xianneng. I'm probably mispronouncing that. This is somewhere in between. I got this actually from Robot Shop, but I believe it's a Lynx Motion motor. And it's nice. It's kind of halfway between. It is a Planetary gearbox. I've used these in my design quite a bit. I found them to be, you know, price-wise, depending if they're on sale, they're somewhere in between here. And also, you do have to factor in sort of the form factor of these. You know, is it going to fit in your robot, in your BB8? And I found this to be a good size, but I'm kind of shifting around because like this motor here is actually in excess of twice the power of these other guys. These are really nice beefy motors, so I'm trying to figure out a way to maybe put that in into my design, or maybe some variation of my design. Now these over here, these are the big kahunas of some of the Planetaries. Similar, I think this is a 550 or an RS 550 DC motor, and this is a Banebot Planetary gearbox. And these gearboxes are these typically are $70, $80. You know, they're nice, expensive gearboxes, and they are all about powerful and being powerful and reliable and so on. You actually, in a lot of cases, you'll buy them separately. And what I have here, let's open this up. This is an example of what you get when you get in your gearbox here. So let's see what we got. So we've got, on the one hand, we've got the Spur gear that goes, or the Sun gear that's going to go onto this motor here, right? So you'd attach that onto that motor, and then the gearbox, and you can maybe see those Planetary gears, I'm not sure, maybe you can, inside. Can you see those? So this is a nice beefy gearbox. I think this is a 16-to-1 reduction. So it's still, even on this 18,000, it's still going to be like 1,000 RPM. So you need probably some additional reduction outside there, because 1,000 RPMs is definitely on the high side. So that's a good example of a separate gearbox, and you'd have to put that together and then basically attach that onto the front of that to make your package of your integrated motor. Yes. Okay. So let's put that back in there. Here is a worm gear motor. Okay. Now this worm gear, and a lot of the worm gear motors you're going to see are, you have this 90-degree transition from the motor, which is a small one, not too different in size, maybe a little bit bigger actually, but similar in size to the one that's on the smaller Servo City motor. And that drives a worm gear, and this also is about 60 RPMs if I recall. And the really cool thing about worm gears is that they can't be back-driven, so they're great for holding a position. Let me show you kind of a mock-up, or not a 3D printed worm drive. And this is sort of how that, imagine this motor here is in line like this, and the gear that we're driving ultimately is this one here. So there's a shaft that goes through that's kind of offset a little bit. Hopefully you can see that. So it would be actually kind of offset with regards to where this the actual motor shaft is. Now the reason they hold up against back driving is that they engage so many teeth, and the reduction is so extreme that basically you can imagine there's no way I'm going to be able to turn this and cause this to spin, because it's basically kind of a threaded, just like threaded like a screw over here. So you can imagine there's no way I'm going to be able to make that turn. And this is a pretty bad 3D printed. It's kind of tricky. I don't know if we can even get it to spin. But the idea is that as this screw spins over here, it will advance the teeth, causing this to turn, right? So this will spin just like a screw, and then that will cause this to spin, and all the while being locked in place. So you get typically a pretty high reduction in between these two, and you get that really strong resistance to being back-driven. So if you have a robot piece that needs to kind of hold its position, this is a pretty good choice. So those are a lot of the motors you're very likely to see and likely to use. Our Spur gearbox motors, our Planetary gearbox motors, our worm drive motors. And over here, this is a really fun one. This is one of the more expensive, I bought this on eBay as well. And this is a pretty quick linear actuator, which is still a DC motor. This is the motor part. And basically it drives a lead screw up and down in here. So let me show you how that works. Hopefully I can do it without blowing myself up here. Let me get rid of the battery again. And even this would need some type of motor controller, because I have to be able to control its direction and control its speed. So let me see if I can... So this is retracting. And extending. A little bit noisy. So just like a worm gear motor, this is really great at holding its position, because it is using that kind of lead screw as if it was a worm kind of sort of thing. So it's really great. It's really strong for doing like pivoting, this kind of a piston action. So you can imagine a lot of really cool uses for these. But you do need a DC motor controller just for that as well. Basically, anytime you have a normal brushed motor brushed motor, you need some type of control if you want to do, like I said, direction and speed. So there's some other different types of motors, and hopefully we'll have another video at some point soon to talk about like servo motors and maybe some brushless motors and that sort of thing as well. But just wanted to talk about these because people do have lots of questions about, what type of motors am I using, what type of motors should I use, and this is a good example of them. So if you're looking for good motors, look for things that draw a decent amount of amps without overheating, hopefully, and have a decent rating in terms of like the kilogram centimeters or foot-pounds. And what that means, the higher the number, the stronger the motor. But basically, imagine a kilogram centimeter, 1 centimeter away from if this was a 1 kilogram centimeter motor, if I put a arm on it that was 1 centimeter long and put a kilogram on it and turn the motor, it would actually be able to turn that, move that around, that 1 kilogram weight, pick it up. That would actually be a pretty strong motor. Some of these are like 5 kilograms. I think this was in ounce inches. So this will take something like 1,500 ounce inches. And what an ounce inch is, imagine, an inch away from the motor. 1 ounce inches, it means it would be able to lift 1 ounce. So 1,500, it basically could lift something like 200 pounds, really, an inch off of here, which is pretty impressive. Now, the further out you go, that's going to drop off. But that's a beefy motor. So keep an eye out, look at your motor specs, look for, you know, high, whether they Newton meters or kilogram meters or ounce inches, you know, kind of you have to do the math. You don't have to necessarily pick up your whole robot with them, but, you know, that if you are moving a big mass inside, you know, for balancing, things like that, you're going to want some pretty reasonably beefy motors. And it may come down to, you know, using them with the right type of gearboxes and things to make them operate the way you expect them to. All right, so that's part of my motor collection. Until next time, this is Eraser Mice here on the Robot channel. We haven't come up with a new name for it yet. Maybe it'll be something BB8 related. Have been calling it the Rolling Robot Project, and I guess all these robots are sort of rolling, but who knows? Maybe we'll make a walking robot eventually. Okay, take care. BB's quick.